This is a practical, I kind of define loosely, use for nerves. Now, I'm not going to show you the depths of nerves or teach anyone anything new. I see a number of people in the audience who have a lot more experience with nerves than I do. I took a class at Lone Star ELIXIR in 2018, and that's kind of where I got started with nerves. But this is a story, and it's the kind of the genre of man versus nature. So, I'm Eric. I'm from Fargo, North Dakota. I've been doing software engineering for a little over 20 years, and I've been interested in ELIXIR for about 4 years. I haven't yet found an employer where I use it kind of day to day. I use it for small side projects, scripts. If I have some data processing I need to do, it works a lot better than Java for that. And nerves I got into a little more recently. As I said, I took a class at Lone Star in 2018. And I've always been kind of interested in embedded systems and things like that. And I have all sorts of uses or ideas and uses for ELIXIR, but I also like to do other things too, like kayaking. So, it's not a lot of spare time. So, a little bit of background on our story. So, Fargo, known for wintry weather. And this past winter, no exception at all. January was a little warmer than normal, but then the Arctic air moved in and the average air temp was about 6.5 degrees Fahrenheit. February was just cold all month, average temp less than 1 degree Fahrenheit. Set a daily snowfall record and a monthly snowfall record in February. March started cold and then warmed up. On Saturday, March 9th, I was preparing to go cross-country skiing with my family. There's a golf course about a mile from our house where they do skiing in the wintertime. And when I opened the entryway closet to get some jackets out, I noticed water dripping from the light fixture in the closet. Needless to say, that is not what you want to have happening. And like water always does, it goes all the way down, so it ended up in the closet in the office below. We had to clear out that closet, both closets, and luckily nothing was damaged, and we got the bonus of reorganizing both of the closets. And at that point I kind of realized this water could only be coming from one place, and that was the roof. So I crawled into the attic, and there was a river coming down the wall in the attic. So this is some of the ice on the roof. There's a massive ice dam up there. This is a picture after a couple hours worth of work chipping out ice. I figure that I took out about 200 pounds of ice off of the roof. And it had warmed up enough that it was melting right next to the house and running down. Now the day after this, we got another 9 inches of snow. So I didn't get any pictures of the snow on the roof, but I was up there shoveling it off the next, after that 9 inches, and it was knee deep up near the peak of the roof. Towards the edge of the roof, it was almost shoulder deep on me. So that's a lot of snow. So I had to come up with a plan to keep this from happening further. You can get into all sorts of things about, more insulation and, trying to keep it colder up there, things like that to keep things from melting, but, I decided I needed something a little more immediate. So I decided on these heating cables. I even bought some to try to prevent further problems, but as the weather always does, it didn't work with that. It warmed up almost immediately. You know, the next week it was in the 40s. Everything was melting anyway, and yeah, the problem kind of took care of itself for that season. But I knew that next winter is likely to be the same. So the problem with these things is they use electricity, right? A lot of people turn them on in October or whenever it starts getting cold, and they turn them off in April. You know, just unplug them. Well, that runs 24/7. That's a lot of electricity over the course of a winter season. And I thought, well, I could probably just turn them off and on with a switch, but I have a tough enough time remembering to turn my Christmas lights on and off each day without having to try to remember to turn this thing off and on each day too. They make these thermostats that go along with them. You know, they look kind of, I'm not sure how weatherproof these things are. They don't really look that good to me. And they cost about $70. So I had an idea. So I've got a Raspberry Pi sitting around, right? You know, I like nerves. I want to mess around with that sort of stuff. And these power relays, they're about 10 bucks a piece. Certainly I could come up with something for less than $70 that would do the trick, right? Yeah, then I started considering a little bit more and trying to figure out, well, how am I going to hook this thing up? Well, I could get a box and put it in the closet and run electricity to it and wire everything up and then run electricity up to some outlets on the roof. But then I figured it's going to end up looking like this, right? You know, complexity, right? And then thinking about the resale of the house, it's like, well, that's the last thing somebody wants to do is open up this panel in the closet when they're inspecting stuff and find this mess of wiring, right? You know, what is this thing? And, you know, it just seemed kind of amateurish. And then I started thinking about it a little bit further. That's kind of a fire hazard too, you know? So I was trying to come up with some sort of a solution. How can I switch a power load of some sort with a Raspberry Pi, and preferably something that is UL listed, or, you know, something that if the house should burn down for some reason, my insurance company is not going to deny the claim just based on, hey, we found this thing sitting in your closet, right? So I started looking into home automation solutions. And non-comprehensive list, there's Wi-Fi, there's ZWAVE, there's Zigbee, Bluetooth Low Energy, X10, which has been around for, 25 years or so, Insteon, which is a more proprietary standard, Universal Powerline Bus, and all of these things have various trade-offs between price, openness. You know, like I said, Insteon is proprietary as far as I know, and popularity. I mean, I want something that's going to be around for a few years anyway, and the more popular it is, the more likely it is to have community support too. Because as most engineers, I'm a little bit on the lazy side. If I can find something that somebody else has done, then I don't have to do it, right? So I added some outlets to the roof, and kind of up there to the side of the outlets, you can see where the problem area is. So I decided on the ZWAVE protocol because it seemed to have at least some community support. It was relatively inexpensive compared to some of the others, and it's, well, more or less open. I guess I was able to find the spec online, or a spec of some sort online. So I figured, well, at least there's something I could work with, or maybe there's a chance somebody else has worked with it. But I started thinking, well, should I create a library? Is there an existing one I could use? And if I create one, how complicated is it? This ZWAVE spec that I found is a few hundred pages long. That sounded like good bedtime reading, like when I have trouble falling asleep, right? And ELIXIR has awesome facilities for working with protocols, with pattern matching on binaries and things like that. Do I really have all the time that I would need to write this thing from scratch? And do I know ELIXIR well enough to do this? I mean, like I said, I've been kind of interested in ELIXIR for about 4 years, but as I like to tell people, it's kind of the 4-year-long Hello World project. You know, haven't really delved into the depths of it and things like that. You know, could I use a NIF? What do I know about NIFs? Not a whole lot, there again. Maybe I could find an existing library in another language and use that with NIF, maybe. And ZWAVE has got a lot of support in the open source community, but then what native language do I use? C or Rust? Rust has advantages, you know, it's pretty good at speed-wise, like C, but it's got a little bit better facilities for keeping you from shooting yourself in the foot, you know, better memory management. And there's the Rustler library, so we could use Rust with NIFs, but maybe there's another way. Well, I did find that somebody, at least, had started out with a library, and it's kind of nice. It's got very few external dependencies, actually none, maybe. You know, I like this disclaimer here. This is experimental. Do not use in production. Well, I figured I could probably, you know, deal with that a little bit. It wasn't fully implemented. It still isn't fully implemented. At startup, it's got a startup method with it. It creates a gen server which listens for messages and routes them to the appropriate device once you get a list of devices. It's got on and off messages, which, hey, I like that. Use these switches. And it's got an event bus which can be used to listen for state changes and node changes and things like that. Well, then I thought, okay, so I kind of have this sort of figured out. How can I make this cooler? So I said, why not get fancy with this? We'll use Scenic and hook it up to a touchscreen display, you know? So, you know, these things only cost about $80. Sounds good. Scenic is awesome, by the way. If you have not used it at all or looked at it, you really should. I like the touchscreen support and the support for nerves, which is really cool. So here's a code sample that I have, and the way it works is when a button is pressed on the screen, we update the view and make a call to our main listener, which then forwards that call off to the ZWAVE library, which then sends that on the event bus to whatever node is listening for that. In this case, it's a switch node. And then at some point, I hope to have it working back the other way too, where we can listen for events coming off of the ZWAVE library and send them back to update the screen. You know, as most projects go, I mean, this is very far from complete. I've got it pretty much turning a switch on and off right now is where I'm at. My hope is to add some thermostats and things like that. So as far as nerves, I'm kind of using the standard Poncho project type paradigm where, you know, my main nerves firmware project uses the ZWAVE library and the Scenic viewer as dependencies and then pulls in their config. things like that. I found that when I started kind of working on this, the poncho project concept just kind of clicked for me finally. I was having a tough time figuring out, well, how is this different from the umbrella project? And it just was not working until I actually started trying to implement it, and then it's like, oh, makes a lot more sense now. So on my next slide, I've got a quick little demo of what compilation looks like for this. And I should mention, yeah, this, it really goes pretty fast, I think. And then the nice thing is, once we have the firmware compiled, there are so many options for getting it onto the device. We can use the mix firmware.burn to burn it to the SD card and plug it into the device, which I was finding with the touch screen set up on top of it, the cable that goes to the display is just in the wrong place where I have to reach around it with my fingers to get the SD card in and out, which makes it really difficult because I don't want to unhook and hook the cable every time either. So the really nice thing is being able to upload the firmware over Wi-Fi. Early on, I ran the firmware.gen script to generate an upload.sh file, or a script file, which I can run. And as long as the Raspberry Pi is connected to the network, it will upload the firmware. And the next slide demos that. So Nerves Init Gadget is the library that provides a whole bunch of nice things. The CAD pulls a bunch of these dependencies in together, like the over-the-air firmware updates. It's got system clock initialization, NTP support for Nerves time, and it's got access to the IEX console by SSH, and you can transfer files with SFTP, and logging with Ring Logger. I mean, kudos to the people working on this stuff. You are providing very nice tools for people to work with this. So now, next I have a demo of my application. Like I said, it turns a switch on and off right now. It's not real fancy, but I got that much working. And because I've seen talks before, I'm not doing a live demo. I recorded a demo. So here we have the Raspberry Pi with the touch screen and the Z stick, which I'll touch on that a little bit more later too. Then over here we have the smart switch and my trusty fan, which is plugged into the smart switch. So we'll go ahead and boot up the Raspberry Pi, turn the power on, whistle while it boots. Doesn't take too long. So we have our off and our on. Yeah, I'm not a UI designer, not by any means. Hey, we turn it on, and the switch is on, fan's on, and now we turn it off, and the fan goes off. Yeah, hey, encore. We're gonna do it again. Turn it on, and turn it off. So, one of the really nice things, I should mention that Z-Stick is really cool because you plug it into the USB port and it comes up as a serial device. So the support is there for just reading and writing to it. There are libraries for it. It's not, you don't have to do a real fancy hardware initialization or anything like that. It's all kind of either self-contained or, well, probably the library I'm using does a lot of that behind the scenes, but it's a lot nicer than having to compile firmware or a Linux device driver or anything like that to put in it. So ultimately, I'm kind of bad at math, as you can see. Fortunately, my family is forgiving. You know, they like my hobbies and stuff like that. So I didn't save any money by any means, but I learned a lot of things, and I had quite a bit of fun in the process, learning things. And I'm going to keep going with this and see how far I can get. I mean, by my calculations, I've got at least 3 months until the snow starts flying, or at least until it gets knee deep on the roof. So I would have to say that the takeaways I have are try something new. Even if you haven't ever delved into nerves or embedded programming before, try it out. It's fun. It's not expensive. You can get a Raspberry Pi Zero for very little money. Really the only reason, well, 2 reasons I'm not using the Raspberry Pi Zero for this one. The first one is the touch screen. I'm not entirely sure they work with the Pi Zero. I know they work with the Raspberry Pi 3. The other one was I'm not entirely sure if the Pi Zero provides enough power on the USB to run the Z stick. And since I had a Raspberry Pi 3 sitting around, I decided just to go that route. I didn't even try it out with the Pi Zero. Funny thing though, with my laptop that I'm using, I switched laptops a couple months ago, and I had done some development prior to that working with the Z stick and trying to get things working with the Z stick. Well, then I tried it with my new laptop, and I could not get Linux to recognize the Z stick at all. I started trying different USB ports. I found out this laptop's got about 4 USB ports, and there is 1 USB port on this laptop that will work with the Z stick. All the rest of them give me an unrecognized device, but the other one works perfectly. I don't know what that is, but the other thing though is have a plan, you know, but expect to change your plan. Change your plan several times. And most of all, have fun. So we've got a slide full of links and resources. So anyway, there are a lot of resources for this sort of thing. And for that, I will entertain questions if anybody has any.